the companies, yes, have come to us, I think largely because of this discovery that common is rare and rare is common. So what they're dealing with, of course, is this sort of immense amount of information, lots of naysaying around how much it's going to cost to interpret that, who's going to contain that, who's going to be the arbiter of what's reportable and not. We've been approached to decide what are the reportable results and what do you do with incidental findings, et cetera. So we've been involved in a whole host of sometimes 4-year projects to decide what do you do with incidental findings and what's incidental and not. What will be the business model for these companies, everything from the prenatal non-invasive screening and testing part of the equation all the way through the lifespan. And I think the lessons learned here for us are this is a really cutting edge technology. There's a lot of academic organizations, institutions that have adopted it pretty quickly, except that they don't know how to manage it and they haven't been able to figure out how to get it reimbursed. What we've been looking at is when is it meaningful and how do we get it to be meaningful more quickly. So some of the things I've been talking about in terms of aggregating lots of data are really important to these companies. So if this information could be held in an honest broker, trusted broker kind of situation where you can start to reduce the noise that they're finding and start to increase the meaningfulness of these results, they will succeed much more quickly. So the kinds of things we've been working with them on are how do we educate clinicians? How do we set up repositories that are these kinds of honest broker, and Genetic Alliance is working on one of those right now. And how do we start to understand explaining to the payer community the importance of this? So we have met with a whole host of individuals and companies, and in the reimbursement community I serve on the, in fact I'm now co-chair of the IOM roundtable on translating genomics into healthcare, into medicine, and we've begun the dialogue with them about what's meaningful, what kind of evidence do we need to get to what's meaningful, and how can we do that in a way that allows evidence to be aggregated as we move through the course of understanding, rather than waiting until some switch is flipped and we then say something is worth being reimbursed. Globally, again, there's a tremendous diversity of what people have an appetite for and what they understand. So we see in countries, for example, like Germany has actually legislated that you cannot take your whole genome sequence home with you, whereas in many countries, it's certainly your right to have that information yourself. Somewhere like the UK has the UK Biobank project and has done a lot of work in ethics and kind of responsible use in the country. Other places like Estonia and Iceland have decided that they're all going to be sequenced and they'll all share their data. Different kind of ethos. When we get to especially developing nations, we're finding two things: either a super sensitivity to having that data be used, and we saw that, for example, when we did the haplotype map projects with NIH, and I was on a team that looked at which cultures were sensitive to what. Those cultures that have been exploited do not want to be exploited anymore, and they certainly don't want that information released in ways that would then characterize the culture. On the other hand, we also find cultures that don't understand at all what this means, and don't have even the literacy level of the US, which is horrible, so it's less than horrible, and they have been easily preyed upon, I think, in terms of developing biobanks of their information. One project that I just started to work on is one in India, where we're looking at what, with so many people and such a ability to have a high-tech solution in many places, despite the poverty, what would it look like to do this level sequencing and data aggregation and sharing, but do it in a way that protects the people in their cultural context. We've looked at that first by looking at things like the semiconductor industry, because it had a period like this, and it decided for very political reasons, because we wanted to be ahead of Russia and China and other countries, to really push for collaboration. And what we saw there was a real breakdown of IP in a monolithic form to lots and lots of IP on lots and lots of pieces. So apparently, and I'm no expert at all on this, but the average laptop has couple thousand patents on it, and lots of people get royalties from all the parts of the semiconductors, et cetera. So I think we're going to have to see some of that, and that might be microattribution. It might be understanding what do pools of patents look like, and the prices are the benefits are much smaller than they would be. There aren't any blockbusters anyway, so I think people have kind of gotten over that. I also think we're going to have to see some shifts in where we draw the pre-competitive line, and you're right that there's going to have to be then some realignment of how do you commercialize. So the experiment we're trying with this project called Archipelago to Proof of Concept Model, which is a long name, ARCH to POCM, with a group of academic groups, industry, again, probably 10 companies, is to say, what if you drew the line at phase 2B? So everything before 2B is pre-competitive, and everything after that is competitive. And so if all that fodder was in the system and you were sharing company to company, academic group to academic group, but at the point where you took the onus to then commercialize from phase 2B on, you could do all the typical things around commercializing in terms of a lockdown IP structure, et cetera. Would that work? And we don't know the answer to that question. And again, trying to look at other industries and say, what have they done? Because they have had to go through this transformation and not be the single telephone company or the single processor company, that sort of thing. Again, health seems more gnarly and trickier than anything else, in part because we have some kind of moral outrage around it. We've also abdicated for a long time to a patriarchal structure. And it's embedded big time in academia, which is 2,000 years of being ivory tower-ish, is really difficult to overturn. Imaging is another area that we've gone to say, what can we learn from imaging that we can apply to genomic and genetic diagnostics? What we've certainly said it's absolutely critical to have the imaging repositories. There's been some efforts towards standardization that have been better than ones I think that had gone on in genomics. Things like our Genetic Alliance Registry and Biobank, we made sure that we could deposit images as well as everything else, because while the world that we travel in is fascinated by the Moore's Law and the decreasing cost of genomics, et cetera, we know that all the clinical data is going to have to be really critical, and that images are going to be part of that. It's still a real problem when you get down to real projects. I mean, yesterday I was on the phone on a Sunday with somebody. We're working on a project to look at stroke in PXE, and the images are coming in from all over the world, and the platforms are all different, and the way to read the images, they're just MRIs of brains, are everything from films to CDs to digital transmission, and then the software needed to look at them is all over the place too. So I think it's better, but it's not great, and that it's absolutely going to have to be part of the equation in terms of figuring out what does all this genomic data mean. And I'm going to put my money on the clinical side, but in a philosophical way, not necessarily because of the McKessons or the Cerners. I think the people will win, in the sense that if every one of us is walking around with enough information aggregated with everybody else to find solutions, then that will win the day, rather than the disembodied stuff on the bioinformatics side. So you might have a DB gap or a GAIN or a academic repository of some kind, but it is a mom and pop solution. They usually don't talk well with other systems once they get to a point where they do want to bring something to market. They forgot that they need actually other data. They get to FDA and they have the wrong biomarkers, et cetera. So I think the systems that are expanding and growing on the clinical services side seem, to me at least, from my, and again it's a naive point of view, to be able to absorb better the changes they need. So I think I have hope that there will be, and that's why probably most of my time is spent on this thing I'm just calling the movement, that we get empowered about our health and that we decide we're going to take control of it. I think you're right that lots of things right now are useless and don't make sense in terms of different populations, et cetera. And how long is it going to take? You know, our appetite for things is really low, and we're very slow to change. So I think about, if I was a major pharmaceutical company, would I just be buying a rare disease company? And that would be my solution to figuring out how I'm going to stay alive, you know, in a world where there's no blockbusters anymore and when it's not working to do the same old, same old. But their appetite for risking change more quickly is low. Will consumers get to the point where we will do the takeover we've done in music and publishing and computers and banking? And for some reason, we're much less inclined to demand that. And I think in part because it's not something we recognize as easily. You know, we recognize if we can't get our money out of our bank. We recognize if we want to listen to a song tonight and we can't get it. We don't quite recognize the changes we see in our own health, whether it's that we gain weight gradually over time or our blood sugar rises. Those things tend to be chronic, slower, less apparent to us. So it's been the army of people who have had the wake up, you know, in the middle of the night. I mean, when Pat and I had our children diagnosed, I say we crossed a line. And I'm sure all of you have some experience of that, where yesterday was a completely different day. And today, and whether it's the death of a parent or a grandparent or the diagnosis of disease, and then we kind of forget that. It no longer stays urgent. And what we're trying to figure out is, how do we keep a good level of urgency, something Pat has called tempered urgency. How do we keep tempered urgency as a driver and not lose it? Because we lose it. We say, yeah, that was then and this is now. Or we get a kid diagnosed, or our next door neighbor does, and we say, we should fight for curing autism today, and we forget it. And we even find it in the disease groups. So they get established for, you know, curing autism today. And now the 10 autism groups sit around in a circle, and I just gave a talk to them a couple weeks ago, and they talk about how do the foundation succeed, and how do they raise money, and how do they get name recognition and brand recognition. They forgot that their most pressing need is to cure autism today. Wouldn't it be to throw all their data together and work together? So, you know, I think our human nature is to forget the urgency, whereas for some reason we find it much easier in terms of what do we want to eat and what music do we want to listen to and things that are more immediate. So it could be that it's going to take 50 years. I certainly hope not. I hope that it's faster than that, and maybe it'll be subsets of people who decide that they want data and that they will move it more quickly. I really don't know. Other industries have turned over pretty quickly. I mean, 20 years, 30 years. It will be interesting. I think our answer's mixed. I think it is, we do have some tremendous successes in translational research, and we've seen some change even in the practice of medicine based on these translations. I think on the other hand, we don't have systems that support that. So we have this truncated piece where laboratories, whether they're commercial or academic, don't share with each other, even within the same institutions, whether it's a company or academia, and certainly don't share with each other. And so there's not the acceleration that we need. It doesn't work anymore. To find a gene, you could sit by yourself and sit in a lab and score gels and figure out where that gene might be. To do translational medicine means really a lot of moving parts, a lot of pieces that need to come together that we have not yet developed systems for that will accelerate that process. And I think you're right. At the end of the day, and again, Pat and I said this when the kids were diagnosed, we're trying to do in one lifetime what takes lifetimes. And I think that's true in medicine and science. You know, these accelerated discoveries are accelerated, but they're accelerated over decades, not a couple years. And we're all impatient for various reasons to get that done much more quickly. And so I think one of the pieces is, for all of us, is to figure out how do we support the systems change you need, because that's not a piece that, you know, there's not a VC group that says, I'm going to support systems change and change the way things are done in general, or a group of companies that decide we're going to support systems change. So figuring out how we're going to support that as a culture would then accelerate translational science in a way that I think would make all of this more meaningful for all of us in our view, which is just our lifetime, which is a short time in terms of science. And you know, one would hope that we, as both a culture and a species, would figure out that we really need to crack this nut to get things to go faster. certainly finding the gene was important, and it told us and taught us a very important thing, and that is before the disease had been characterized for about 100 years, and everyone was looking at elastin because that's the thing that's degraded in this disease in the eye, the skin, the arteries. And when the gene was discovered, and in fact Pat found it by looking at large amounts of data in Excel spreadsheets and saw patterns, it was a gene that is in the ABC family of genes, which is actually in the cystic fibrosis family, which is a membrane transport protein. So a completely different direction. It's found expressed largely in the liver. It's a liver disease. It's a metabolic disease. It's not a structural elastin disease. So like, whipped our heads around and basically taught us that all of us perseverating in our little silos is probably a bad thing. 100 years of research on elastin has been useless to us. It's a secondary effect of the disease. So now paying attention to cystic fibrosis, to lysosomal storage disorders, to Duchenne muscular dystrophy, all these other things makes much more sense. And then what we then moved toward was trying to understand what does this particular ABC transporter do. And